Let's have some fun and analyze the capabilities of ChatGPT-4o. So I just got access like last week or so to ChatGPT-4o, and I still need to test the waters, test different ways of using it. And today I had the idea of inserting my dissertation. So if you check out my dissertation, of actually using, like, this is really the most significant stress test I could think of. So we have a dissertation, like it has 161 pages. Maybe let's make this a bit wider. So we have 161 pages. So it's a lot of, the context window is quite large, right? We have algorithms, we have complicated terms, programming models, different concepts, graphs, charts, summaries, scientific analysis. So we have a lot of like challenging stuff here in the thesis. And I thought, okay, why not throwing in my thesis, asking ChatGPT 10 questions to find out whether it can answer the question, whether it can actually understand the dissertation better than I do, because I basically forgot most of the concepts, most of the like specific concepts. If you would ask me those questions, I wouldn't be able to answer most of them at this point. Okay, so let's dive right into it. So here I have downloaded the thesis dissertation here from the web. I just put it into the chat window of ChatGPT-4o, the new version. And again, it's 161 pages, so it's a significantly sized document. Okay, so I think I have the thesis open here as well. So let's maybe put the thesis here so we can test some things. Okay, and then I already prepared some questions. I have not tested those questions yet, so this is like a live test with me together. Okay, so let's maybe first prompt engineer it a bit before asking the question right away. In this chat, play the role of an interactive thesis that answers all questions I ask with respect to my thesis content. Good. Let's check if it can figure it out. Okay, so please go ahead and ask your first question. The first question is, give me all GitHub repositories mentioned in the thesis. So I've already checked out here. If you search the thesis for GitHub, we get a few results. Like here in the footer, we have many of those GitHub links. So let's ask it to give us all GitHub repositories of the thesis. This would be something that is highly relevant. And I haven't tried this. Yeah. So let's see. Yeah, beautifully. Seems to work, right? It gives me the GitHub for all the major parts of my thesis. These are like the 4 important GitHub repositories. I don't think it got all GitHub repositories, but okay. Are these all, or are there more? So let's ask it if there are more GitHub repositories so that it can extract everything. Yeah, okay, now it also has Git graph. Previously it didn't. Okay, yes, it. Okay, so good enough, right? I think it's good enough. So let's move on to the first question. I think it completed the first question better than I would have done, right? The second question is, write a 1-sentence research statement based on the thesis. And I already like found something in this thesis. We motivate, develop, and analyze novel graph partitioning algorithms tailored to distributed graph processing. So this is a thesis statement. So that's maybe thesis statement. Let's search for the. Let's search for one term, utilization. Here it found something. Okay, so here we have the research statement and the thesis statement. So let's check if it can provide the research statement. The thesis aims to develop and analyze novel graph and hypergraph partitioning algorithms tailored to distributed processing systems. Yes, I think this is exactly what it does. Focusing on reducing communication costs, improving processing latency, and addressing dynamic query workloads and heterogeneous network conditions. Okay, so far so good, but this is like still quite easy stuff because we are only at page 24. So it might be able to do these questions about content in the beginning better than content later. So in the later part of the video, we will also check content that is very specific content embedded in the depth of in the meat of the thesis, right? Also like having mathematical questions and stuff. Okay, so but let's first start with continue with something easy, like what are the names of my kids? Actually, in the acknowledgement in the beginning, I mentioned them, the name of my kids. So let's see if it can find the names of my kids. Yeah, okay. So it it figured out the names of my kids easily, right? Based on the information. So the AI is really smart. We should be really concerned, right? Because every information we give out there, it can be quickly retrieved by AI. This is not like database search or so, right? It understands the text, it understands even a corpus of huge information. Like this is a 160-page thesis. It was like the distillation of 4 years of work for me. And everything I wrote basically condensed in one document, a huge document. And it quickly figures out all information somebody would like to extract from the document. Now think of this, like scale this idea by 100. So which means that it would include all the data, all the information that you always publish on the web, and it would be able to easily extract everything that is publicly available out of this information because it really understands this stuff very well. Okay, so let's continue with another one. What is the name of the hypergraph partitioning algorithm, and what's its main idea? And we called our hypergraph partitioning algorithm HYPE. Yeah, so let's maybe go here to hypergraph partitioning. It was in the later part. So AI could already have answered this question, right? While I'm still searching for the chapter, AI would already have provided an answer. Okay, so you see, we have now hypergraph partitioning algorithm, and we want to have the name. The name of the partitioning algorithm is called HYPE. So let's see if AI knows this. Its main idea is based on neighborhood expansion. So I'm looking for this word basically. Yeah, the name of the hypergraph partitioning algorithm is HYPE. The main idea of HYPE is to partition the hypergraph by using the concept of neighborhood expansion. And it can even explain it, where the algorithm grows k partitions separately by expanding one vertex at a time over the neighborhood relation of the hypergraph, focusing on optimizing for partitioning speed and quality, especially for real-world hypergraphs with skewed degree distributions. I mean, I cannot tell you. Probably you didn't understand this concept. I don't understand it 100% either at this point, right? I have forgotten most of those concepts, and I wouldn't be able to explain it now, right? I mean, even having written every word of this, I wouldn't be able to explain it to somebody asking me the question now at this point after years. So this is really interesting stuff. It's really like mind-boggling. This is a 160-page document. AI will significantly change the way we do research. It will change the speed of research itself. So we will expand our human capabilities faster. This really happens because if you as a researcher, if you have this tool, if I would have had this tool as a researcher, my productivity would be at least twice as big, which means that we as researchers can now accelerate our progress, and we can push humanity forward faster than ever before. And this is not just empty words. This is really happening. You can see it in front of your eyes, right? It understands my research work. And a lot of research is just understanding the corpus of research, the literature, identifying research gaps, and then filling the research gaps. And AI is already able to automatically generate better algorithms, like better sorting algorithms that are faster than the best existing sorting algorithms. And we have seen something similar recently. There's some published papers that show that AI figured out new sorting algorithms that are now added to the C++ library. Okay, so let's continue. I want to ask you the highly specific questions. What are the two types of vertex-centric programming models? And this is actually very difficult now to figure out, right? Because it's somewhere embedded deep in the thesis. So let's see if it can come up with the vertex compute model and the gather apply scatter model. Yeah, okay, so it figured these out perfectly. The two types of vertex-centric programming models mentioned in your thesis are vertex compute model, gather apply scatter model, and then it explains the models so beautifully. Okay, so now let's maybe have a very specific questions, like follow-up question. Follow-up. Who proposed the vertex compute model? Proposed by Google in their pre-exist system. Wow, this is insane. This is really insane. The retrieval augmented generation here that is happening under the hood is insane. And it really shows like the progress of OpenAI is mind-boggling. This is the most disruptive company on the planet. Okay, so next test we have one of the concepts, also like at the later part of the dissertation, the advice concept. You can see advice here somewhere, like chapter 4. So it's like page 71 plus. I want to ask you to explain the four main concepts of advice. And the four main concepts of advice, which is my approach for graph partitioning, is adaptive windowing, lazy window traversal, adaptive degree-aware scoring function, and spotlight partitioning. So I'm looking for those terms. Let's see if it can figure it out. It's also really quick. It is so quick. It is much quicker than a human. It is much quicker, more precise, and with a higher level of understanding than a human researcher. I mean, think about this. Think about the implications. It does it perfectly, right? The perfect terms we coined here in this research it gave us. Okay, so let's maybe dive in the evaluation results. Also, did it understand the evaluation basically? It effectively balances a trade-off between partitioning latency and graph processing latency. So let's ask for specific numbers. Numbers in the result. So now it seems to be needing to read the. Oh wow! Now it really retrieves all the numbers. Yeah, it's beautifully presented as well. So I think it really did a great job. Awesome job of extracting the specific information. Okay, so let's have another fun one: identifying a research gap that is filled by QGraph. This one would be really relevant for all researchers who need to figure out research gaps all the time, right? I mean, you need to figure out research gaps as a researcher and then fill the research gap. So if you read a paper, you can just throw in the paper and figure out the research gap. So this is really mind-boggling. And so the research gap addressed by QGraph pertains to the efficient processing of multiple localized graph queries running in parallel on a shared graph structure. Yes, this is exactly what it does. Existing graph partitioning and synchronization methods do not consider query locality and dynamism, leading to high query latency and suboptimal performance. QGraph fills this gap by introducing query-centric dynamic partitioning and a hybrid synchronization model, already fallen asleep, that adapt to the dynamic workload and hotspots of graph queries. Yeah, this is perfect. Perfectly, like perfectly done. So at this point, it already, like all 8 questions I posted, it answered to my satisfaction. Now let's have something more challenging. State the problem formulation of hype, the hypergraph partitioning approach, in mathematical terms. So it should also give me the math, right? And you see here the hypergraph is given as the mathematical notation graph consisting of vertex and edges, set of vertex and set of edges, and then also like go through the cut and everything. You see, like, I mean, this is just insane. This is just so insane, right? I mean, it does a latex. It understands a formula. Look at this formula. It really gets this formula. This is so insane. I cannot. My mind is seriously blown right now. Wow, I would not have expected this. I would not have expected that it can also give me the math, the formula, the problem formulation, and everything. So now let's do something. I mean, let's do another question I have not prepared, but I don't think it will be able to do this, right? This one is a figure. This is just a figure. You see, if I draw it, this is a figure. I give a figure. Let's ask if it knows what Hello Killer 77 is. This is just a text on the figure. So it would have to do some OCR, object recognition, object character recognition on the thesis. I don't think it will be able to do this, right? But let's see if it knows what it is. It is a Reddit user. What is Hello Killer 77 in the context of the thesis? I don't think I have mentioned this name in. I certainly have not mentioned this name in the thesis. Probably it won't be able to do it, right? Wow. Wow, it is able to. I cannot. No, this cannot be true. This cannot be true. This cannot be true. It did the object recognition on all figures as well. I did not expect this. I thought, okay, maybe it understands the text, but I did not give this user. I did not provide any like textual information about this user. This is what blows my mind. I only gave this one figure, like a screenshot of the Reddit user, but I never even mentioned the Reddit user. Wow, this is insane. Look at this. Here, look at this chart. Here, this is not text here. This is not text. This is just a figure, a JPEG file, and can it be that it really analyzes or extracts this kind of information from the JPEG? I mean, it is technically it's easily possible, right? It can extract it, but it actually means that for 160 pages, it automatically analyzes all the JPEG, like the JPEGs even. It analyzes the JPEGs and the contents of the JPEGs as well. It really understands everything as a human being, like a human being. This is insane. We are on a wild ride with AI. I'm telling you. Okay, let's ask the next question, which would be like this could also be only be answered by a researcher, right? Provide some research gaps that are not addressed in the dissertation, future work, and also I'm looking for own ideas. I gave like a section on future work. Probably it will consider this, right? But it will also now provide new research ideas. Actually, GPU-based graph partitioning, this is a perfect idea, especially for very large graphs, because this is already like done in literature in the meantime. But at the point of this thesis, it was a great research gap. So it basically figured out a research gap that was then later filled, which it obviously doesn't know because it only considers the thesis, right? Um, think of the capabilities of future models where you can feed even more work there. But I mean, even feeding one whole dissertation and it's being able to perfectly understand the dissertation better than yourself. This is just insane. We are just on a wild ride here. The future the future is bright. So it gives me additional ideas, incorporating fault tolerance in partitioning algorithms. This is a great idea, actually. I never thought of this. Like if you, it is a distributed system, right? So it needs to be fault tolerant as well. Energy efficient graph partitioning. I think we could write an A paper on this. This is awesome. This is awesome. Energy efficiency, considering it. It is definitely a research gap. Wow, because most people focus on bandwidth optimization, for instance, or latency optimizations. But at the point of writing this thesis, now I'm not an expert in the space anymore. But at this point, I was at the forefront of graph partitioning, and nobody considered energy efficient graph partitioning. It would be a great research paper. Just these four terms. I'm really mind blown right now. Leveraging temporal graph dynamics. Many real-world graphs, such as social networks, evolve over time. Developing partitioning algorithms that can leverage the temporal dynamics of these graphs to improve partitioning efficiency. Wow, this is also a great idea. We also considered this idea. We never figured it quite out or focused on it, but it was an idea, and ChatGPT-4o is able to provide these kind of ideas. Security-aware partitioning, with combining it with sensitive data to comply with privacy regulations. Oh my goodness, this is a great research idea. Yes, I see it. I see it very clearly. Yeah, because if you partition the huge graphs like social networks, you partition the data to multiple machines. Some of the data needs to reside in European data centers, whereas some of the data needs to reside on, say, US data centers. So we need to do the partitioning based on regulation as well. So security-aware partitioning could maybe consider like have an external information that or restrictions on where the data may or may not be placed, and then it could optimize based on these external restrictions. It is a great idea. It is a top A paper conference. You could publish such a paper in an A conference. Wow, this is just, whew. I cannot tell you how my mind is blown. Okay, so let's do some advertisement and close this down. Okay, advertisement. Check out the Finxter Academy. We have a lot of awesome courses on using AI to create next level applications. Here are some of our recent courses, and we will soon launch a new course, a Hugging Face course, which is so great. Finxter creator Dirk, he's an expert on AI programming, and he's also a great educator and an awesome human being. And he has provided us with some beautiful courses how to use OpenAI and ChatGPT and large language models, lang graphs to really push the frontier and include like intelligence into your Python applications. And for example, this can help you building complex multi-agent teams and systems. So if you think of what is a company is a multi-agent coordination system, right? So you have multiple human beings and also now multiple programs working together in a cyber biological system towards a bigger goal. Now you can replace more and more of the biological systems, the humans, with the intelligent systems, the AI agents, by means of like fine tuning and training and optimizing different agents with different strength, and then orchestrating like a beautiful meta organism to build an organization that completely autonomously, without a single human being, pushing toward a higher level goal. Like building these complex multi-agent teams and systems can be powerful. I think the next one-person startup creating $1 billion of valuation will use something like this. Will use like an army of AI agents that work together towards a bigger objective, and which means that you can spin off your company, say with 100,000 workers, right? Amazon has 100,000 workers, or maybe a million workers. I don't even know. I think they have more than a million human workers. Think of the value you could create with a million human workers. And now you can create this kind of value. Just don't use a million human workers, use a million digital workers, artificial agents, and let those do some value. Let those create some value. You need to be creative, and you need to have the skills of actually doing this and plugging these systems together. And this is the latest course. And we have a lot of courses, so check out those courses. You can, if you become a premium member, like a Finxter premium member, you can check out, you can learn all these courses, and for each course you can also download your personal course certificate. So it's awesome, it's great. I'm really confident that this will help you reach your goals in life faster. Thanks for watching this video. Subscribe to the channel, subscribe to our email academy. Just go to finxter.com and subscribe to one of the email pop-ups, and I will try to keep you on the right side of change. And change it is. It's really insane if you think about what I just demonstrated here with ChatGPT-4o. This is the next level disruption. Okay, thanks for your attention. See you in the next video. Bye.